Hello and welcome. This is going to be our second video on solving system of equations, the substitution method. Now, unlike our first method, the graphing method, we're not going to be drawing any pictures. What we're going to learn is how we can use both equations simultaneously to figure out what x and y are at the same time. We're going to do some manipulations here, and the key is the word substitution. So first, let's know what the goal is of substitution method. The goal of substitution method is to create one equation by substituting part of one equation into the other. We'll see what that looks like in just a moment, and what that's going to do is it's allow us to solve for x and y. And the big hint that you're going to use to know how to substitute, to know what we're going to put inside the other equation, is that you're going to look for one variable all alone on one side of the equal sign. So let's put this into practice. I've got a nice little system below. Let's get the pen tool going. There it is. Alright, nice little system. And our first equation, 2x plus 3y equals 18, and y equals 2x minus 10. Well, here we go. I just found a variable all by itself on one side of the equal sign. So what this is telling me is this y can be replaced with 2x minus 10. They are equal, they are synonymous. So what's going to happen is I'm going to go back to the first equation, and instead of writing that y, I'm going to replace it with a 2x minus 10. Now, because there's more than one term there, when I replace it, I need to use good old parentheses. So here we go. I have used substituting to put one part of the equation into the other equation, and that's given me one equation which I can solve for by itself. So now to figure out what x is, we will need to distribute this multiplication to make sure that everything gets multiplied. And I'll write everything else down because we did touch it. We're going to have to play with it in a bit. Got some like terms here. Our 2x plus our 6x gives us 8x minus 30. Alright, we got to add 30 to both sides to help get that x alone. So 8x equals 48. And finally, dividing by 8 will tell us that x is 6. So remember, we're halfway there. We have to find out what x and y are. The last step that we need to do to figure out what y is we need to plug it back into our equation. So you can plug it back into the first equation here, or you could plug it back into the second equation there. The better decision is going to be to plug it back into the second equation, because here the second equation was made to tell us what y looks like. So we'll see what happens when we plug that in. Y is equal to 2 times 6, because remember, that's what x is. 2 times 6 minus 10, which is 12 minus 10. So y is actually equal to 2. There you have it. That is the basic thought process of the substitution method, where we have two equations, and one of them is going to help us substitute into the other one, giving us a one variable equation which we can solve for, and then once we have that variable, we'll plug it back into one of the equations to get the second variable. What I want you guys to know is that it won't matter so much which variable you substitute first. So x's and y's are going to work the same way. You just need to make sure that you're following the instructions of what each equation is telling you to do. So if I were to take a look right here at this example, example A, this is telling me to substitute for y because I have a y equals. So in this system, I will take that 2x plus 8 and I will substitute it in for y, giving me an expression that looks like this. Again, using parentheses because we have more than one number there. However, if we look at our second system over to the right, this is now telling me to substitute for x. So I'm going to take this part of the equation and I'm going to substitute it in for x. So now instead of 2x, I write 2 times negative 3y plus 6, and I continue with the rest of it. So the only real difference between these two questions is going to be which letter we're solving for first. For A, we're solving for y first, and for example B, we're solving for x first. But nothing crazy is going to happen. You just do exactly what the system is suggesting that you substitute for. So let's finish these off one by one. All right. I need my green pen back. Let's get some green. There we go. All right. Finishing off this one right here. Well, we'll need to distribute again. So that'll give me 8x plus 32. Copy that down. Copy that down. When I combine like terms this time, I get 6x plus 32 equals 14. Take away 32. Take away 32. 6x equals, okay, we're going to be negative now, negative 18. Divide by 6, divide by 6. X is negative 3. Halfway there. Okay. So remember, this equation right here that we circled on top, that's made to tell us what y is. It's saying y, I can do better, it's saying y is equal to that. So instead, now that I know that x is negative 3, I'll go ahead and put that in. So y is equal to negative 6 plus 8. In other words, y is equal to 2. So we have solved for both x and y using the substitution method. On to the second example over here. Alright, we've already got our equation all set up, substituted for x. Time to distribute our number in front. Negative 6y plus 12 plus 4y equals 8. I have a like term here and a like term there. Minus 2y plus 12 equals 8. Time to simplify. Minus 12 minus 12 gives me a minus 4. And I need to make sure to divide by negative 2, not just regular 2. But I need to also grab that negative, giving me a result of y equals 2. Just like before, the equation we use to substitute is perfectly made to tell us what our second variable is. So x should be equal to negative 3 times, what was our y again? Okay, our y was 2. So negative 3 times 2 plus 6, negative 6 plus 6, and that happens to be 0. So there you have it. We just did 2 more substitution method problems. In one of them, we substituted for y. In the other one, we substituted for x. And there really wasn't a difference in how we solved them. The only thing that changed was really which letter we found first. Now, on the last part of the notes, I put in this challenge right here. And it's a challenge because you'll notice that neither equation is ready to substitute. That's because we don't have one variable all by itself. But just like with graphing, not every equation was ready to be graphed. We can fix this. So what you're going to do to fix it is you're going to move the other term to the other side of the equation. So it looked to me as though this x was ready to be all alone. It didn't have anything in front of it. It didn't have a times 2, a times 3. The only thing we need to do is take care of this right here. So if I subtract it from both sides, there we go. We will have our x all alone. And now I will have an expression which I can use to plug into our second equation. If you want to see some of these examples in practice, I'm going to do a few more of them in a separate video. So thank you. Again, let me know if this was helpful, and keep plugging away.